Homework 16, the central limit theorem for proportions, video 1. In the previous series of videos, we learned about something called the sampling distribution of x bar and the central limit theorem. In this series of videos, we're going to learn about a different way to measure a sample or population called proportions and discuss its sampling distribution and its central limit theorem. So why do we have something called proportions? Well, first let's define what we mean by a proportion. A proportion is the percent of a population or sample that possesses a specific characteristic. For example, let's say that we had a sample of 100 people and 45 of them were male. Then the proportion of that sample that are male is 45 out of 100, or 45%. The reason we discuss proportions is because sometimes when you're analyzing a variable about a sample or a population, it's not numerical. In other words, it's qualitative. For quantitative data, for numerical data, we can talk about things like means, standard deviations, percentiles, quartiles, etc., etc. But if our variable is qualitative, in other words, you ask somebody a question and their answer is not a number but a characteristic. What is your gender? Where do you work? Do you have a college degree? Are you married? What color is your hair? What's your favorite kind of pet? Have you been to Antarctica? Or any other question whose answer is not a number, then we can't do things like what's the mean answer, what's the standard deviation, but we can look at it numerically by calculating the proportion that say a certain answer. A common example of this are exit polls during election, when they ask people, who did you vote for? Candidate A, candidate B, candidate C. So when they ask the question, the answer is not a number, but we can still describe their answers numerically by saying 20% of the exit poll people voted for this candidate, 35% voted for this candidate, etc., etc. So it gives us a way to describe non-numeric things numerically by simply saying what percent of a population or sample possesses a specific characteristic. Now, there's actually two types of proportions: sample proportion and population proportion. They're measured exactly the same way. What percent of a sample has a characteristic? What percent of the population has a characteristic? But the reason each one gets its own definition and hence its own variable is because when we're done with this chapter, in fact, this is the last section we're going to cover in this chapter, we are finally going to venture into inferential statistics. Just a reminder, inferential statistics are where we try to infer something about a population based on what we know about a sample. So in order to do those things, we have to have measurements for each of a population and a sample. A sample proportion, it's a formula, but I hesitate to even call it that. If a sample of size n, that's the variable for sample size, has x elements with a certain characteristic, 45 males, 30 people who have been to Antarctica, 19 redheads, whatever the characteristic is, then the sample proportion, the variable for sample proportion is a p with a little hat over it. It looks like a little arrow pointing up, sort of. But the variable for sample proportion is read p hat. So p hat is just x over n. In other words, how many of your sample have the characteristic divided by the total number in the sample. So you just make a percent. And it's the same thing for a population proportion. If a population of size capital N has x elements with a certain characteristic, then the population proportion, whose variable is just a lowercase p, is p equals x over capital N. So both of them are pretty easy to understand. You're just answering the question, what percent of the whole has a characteristic? I've got a couple of examples set up over here. These are actually numbers that I just got off the internet. Actually, I asked Siri some questions and she gave me the answers. I didn't write down the exact numbers, I did round them off. For example, the population of the United States is about 328 million. There are about 825,000 confirmed cases of COVID-19 in the US. So the variable here is, do you have COVID-19? The answer is yes or no. 825,000 people said yes, or were tested, and the answer was yes. Now we can calculate a population proportion because we can calculate the percent of the population that has a characteristic. In this case, the characteristic is a confirmed case of COVID-19. So we could say that P equals 825,000 out of 328 million. This will always be a number between 0 and 1 because your numerator will never exceed the denominator and your numerator will never be less than 0. So let's see what we got here. This calculator won't hold the right number of zeros, but I can do a little bit of that and put in a smaller number. 825 divided by 328,000. Oops, I forgot the thousand part. 825 divided by 328,000. Let's take this to 4 decimal places. 0.0025, or if we turned it into a percent, we would move the decimal 2 places to the right and say 0.25%. So according to the statistics that I literally just got off the internet, about 1/4% of the US population has a confirmed case of COVID-19. Now I'm not trying to stir fear or spread panic or anything. I'm just grabbing numbers that have meaning this day and age. But I would be remiss if I didn't point out that out of those 825,000 confirmed cases, there are some that have recovered. I don't know the exact number, and I'm not going to pause the video to look it up, but I do know, for example, in Smith County, more than half the COVID-19 cases have recovered. Actually, I think it's a little less than a half. I forget the number off the top of my head. But let's take a look at a sample. In a sample of 220,000 citizens, there are 123 confirmed cases of COVID-19. This is actually Smith County, Texas. It's not exactly 220,000 citizens, I just rounded it for convenience, but the 123 was current as of about 4:30 p.m. on April 22nd, 2020. If we think of this as a sample of the entire country's population, as opposed to the population of Smith County, or we could think of it as a sample of all Texas citizens, or a sample of everybody in the world. But if we treat it as a sample and we're going to calculate a proportion, then the correct variable is p hat. But it's still just how many have a characteristic out of the total. So 123 out of 222,000, 123 divided by 222,000 is, to 4 decimal places, 0.0006, or if we move the decimal 2 places to the right, 0.06%. So as you can tell, Smith County is way below the national average when it comes to percent of its citizenry that has a confirmed case of COVID-19. But that's all proportions are. What percent of a population has a characteristic? That's called P. What percent of a sample has a characteristic? That's called p hat. In the next video, we're going to talk about the sampling distribution for p hat in an effort to connect sample proportions with population proportions, and that's something that we're really going to capitalize on in the next series of videos.